and today Brian and I are talking with Shane Callanan. He is the VP of DC Systems Engineering over at Advanced Energy, and today we are going to talk about trends and innovation and the fourth industrial revolution and everything that's going on in the industry. So thank you so much for joining us today, Shane. We really appreciate the time.
Thanks, Nicolette. Thanks, Brian. My pleasure.
So before we dive in, can you tell us a little bit, just give us a little background about your journey over to Advanced Energy?
Sure. My background is I'm a double E. I have a Bachelor of Electronic Engineering. And, graduating in Ireland in the mid-90s was one of the sweetest times to come out, to come out as a graduate, because we had a lot of major international companies in Ireland: HP, Intel, IBM, Ericsson's, and everybody was recruiting. So pretty much there was a huge shortage of graduate engineers, for a long time in Ireland. And I actually selected purposely to get involved in the power industry, simply because it was an electronic engineering degree. I wanted to do something in hardware. A lot of the jobs were in software. And as we talk through this process after, you will see how I've come to full circle, where software has continued to chase me throughout my career. But so I started to work in the power industry, worked with a company, Artisan Technologies, up to about 2006. And at that time, then I wanted to take the brave step into starting with a small company. So I moved into a small Irish company, effectively a startup. I was the first engineer in the company in 2006. A really exciting time in terms of gathering, growing, new business opportunities, and did that for about 11 years, and then joined actually Advanced Energy through acquisition in 2017. So, it really, really fun and interesting time to join Advanced Energy, a company growing very quickly. At the time, it was probably around the $750–800 million mark, through acquisition and growth. We're now, after, significantly increasing in size with lots of more engineering teams involved. And that's how I came to become part of the Advanced Energy community.
So you've been in the industry for a while, then it's a good time.
Yeah.
So it's a good time to talk about kind of what we're watching with this, what's been coined the fourth industrial revolution. And mm-hmm. I would say we're kind of in it, right? It's not kind of happening. We're in it now. Would you say?
I would agree. I think that the only reason why I think it's, people may or may not realize how deep we're in it is because we're accelerating so quickly that with every new range of technology that comes out, it's really, we're already after surpassing that. I mean, we haven't really even hit 5G yet, and I see people talking about 6G already. But so we're really moving at a very rapid pace. And what's really interesting is that traditionally the power supply industry had a very slow pulse rate. Switch mode power supplies have been around, since the 60s, even the 50s, even before that. And when I started my career in the mid-90s, they really hadn't changed a whole lot over that period of time. But you can really plot the rate, and it's an exponential increase in the rate at which technology is taking over, even in our industry. And year on year, I can see things accelerating much, much more rapidly as we go on through this process.
So you mentioned 5G, right? And people are shooting at 6G, and they're talking about all this other crazy stuff. How much has the need for energy and power changed over the last, say, few years, even, with the amount of data that's being passed back and forth? And how much will it change once 5G actually is everywhere?
That's a really, really good question, Brian. And the reason why I say really, really good question is because we've actually been looking at, collecting data on power supplies for decades. I'm certainly not the oldest guy, but I'm not the youngest guy in the industry either. And, I can remember back in 2002, we actually had the ability to try to take what is now, the IoT, where it's all about being data driven. We started to look at that in my career in 2002. And I remember distinctly bringing this to a customer, saying, we can do all this crazy fun stuff for you. And really the answer was, listen, Shane, you guys are very good at power. Why don't you stay invested in power? I need volts, I need amps, I need a certain characteristic. But I think if you fast forward, again, it's only 18 years ago. It's not a long time ago. It's only 18 years ago we were being told not to bother doing it, and now it's after flipping a full 180, and the expectation is that we are developing it. And because if you consider, it's all about data-driven decision making, and you get your data from everywhere. Whereas in the past, simply the systems couldn't handle that amount of data. And then the next revolution came along. There was so much data there, people couldn't make head or tail of it. Now with artificial intelligence and now with data-driven algorithms, we can now start to make sense of a huge amount of information. So gigabytes back in the day was big, terabytes became the next thing. Now whatever, so it's not about data storage, it's not about sorting through data. So now the power supply can really start to make a contribution in terms of providing that data to fill in the gaps that are already there.
Do you also see, like, I mean, one of the things we see a lot of things like, autonomous vehicles, and there's a lot of, I want to say, self-power going on, right? In those where they're gathering the power and harnessing it into batteries versus things that are being powered. What have you seen changed in that? Do you think there's going to be a lot more self-harnessing power happening in the future, or is it going to be power coming from, other sources?
Yeah, I think it's going to be a combination of everything. I think as we go through, and even if I give you my experience again in a relatively short time, it's just a couple of decades, but again, the digitization of a control loop, for example, on the power supply, it's nothing new. The only difference is that it was very expensive, and because you couldn't show the benefit, people weren't willing to pay for the difference. However, technology, the cost has come down. We get more bang for our buck. The latest mobile phone, look at the processing speed that's on, things like that. And that's really where I think it's going to be a combination of harvesting everything. So it's going to be kinetic energy. It's going to be, power grid energy. It's going to be efficient transfer of energy. It's from generation right through to usage. I think every aspect of it has been researched in our industry at the moment. And I think it will take time for the full benefits for it to be seen. But there's no doubt about it. I think it would be a combination of all of the above.
So then, I was originally going to ask this question in terms of general, but in terms of power, what should engineers, design engineers now really be thinking? What's on their minds right now when it comes to designing? With all of this transformation going on, especially as it pertains to power.
Yeah, I think, I mean, if I look at both sides of the fence, okay, so if we look at the people who are involved in designing the power systems, and let's take a look at the people who were using the power systems, the key element here is adaptability. You look back again, 2 decades ago, people could choose to be either an analog engineer or a digital engineer in terms of power supply design. I think now those areas are graying. And even more so, even what I find myself looking at now is even looking outside of the traditional engineering courses that we've been taking our gene pool from. And because there's firmware, and because there's much more complexity, and because there's data and machine learning and all those kind of things being brought into our industry, it now means that we have to widen our net in order to make sure that we have the right profile of engineers going forward for the next generation of product. So if I'm at the design engineering side of it, designing power supply systems, what it means is that I have to be ready, I have to be flexible, and over a period of 3 to 4 years, I have to keep redefining myself as a design engineer. You have to keep learning, you have to keep adapting. On the other side of the fence, traditionally what used to happen is that power supplies were a very transactional item where I purchased the power needs. Now what needs to happen quite clearly is that because people are continuing to push the physical boundaries and continue to get more and more energy, much higher energy, much faster, much more specific profiles, it now means that in many cases the power supply is the barrier for enabling the end customer's innovation. So I would encourage engineers on the using side of it to make sure that you continue to build a symbiotic relationship with the vendors, because these are the engineers who will look forward. These are the engineers who will converge on your roadmaps as you go forward. And together, if we understand the needs of our customers, and if we can develop the technologies, if the two converge further down the line, it means that now the power supply systems can become enablers to new technology. And we've seen that across a range of scanning electron microscopes, for example. You see it in medical treatment. Again, I mean, think of the worst case scenario of, esophageal cancer or something like that. We're heading towards a time very quickly when it would be non-invasive medical treatment to treat cancers that were in the past either very poor ending for most people, or else what it might be is a very invasive surgical procedure. And we're seeing huge changes year on year, and it is the power harvesting the energy and getting it into those cells, for example, very quickly in a very precise manner that will allow the treatment that was typically a surgery be moved into the clinician area. So really huge changes in revolution. So you started the question by asking, what is it that I would advise people to do? It's, be adaptable, be prepared to redefine yourself, embrace new technologies, and build a symbiotic relationship between the vendor and the user. And that's how we will really progress in terms of the industries that we're targeting.
Do you think, I mean, I know a lot of people focus on this, but how important has also power management become? Managing the power resource.
So you're talking about when we say power management, could you just clarify that so that at least I know I'm answering the right question?
Yeah. So basically, as you're controlling the power, you're managing the power that's going through this different systems, like you're building whatever medical device, robotics, you're managing all that power. How important does that become into your design aspects?
It's critical, Brian, and the reason why I tell you is because, again, let's go back to that medical procedure example. If you look at traditional methods of treating cancer, for example, and I'm not a doctor, but I'm just telling you what I've learned in terms of engaging with our customers. You look back in the 50s when chemotherapy was first being developed, it killed everything, good cells, bad cells, and the aim then was for the body to recuperate and grow itself again. And often at the start of these experiments, the cure was worse than the illness. Mm-hmm. And what we're starting to see now is, even in terms of the medical industry in particular, you have positions in hospitals, and it's the chief experience officer. These are new positions that are opening up, because in the past it was the doctors, it was the surgeons who dictated what procedures were and how they were carried out. Whereas now there's a move to putting the patient in there as almost as a customer, and it's all about the experience. It's all about the speed of recovery. It's all about minimizing the actual invasive procedures that are necessary. So what's happening is that there are new techniques that are being developed in order to, again, just treat the illness and even at a cellular level. So in terms of managing the power that is blasted into a human body, it's all about the recovery. And what it is, and the way that you minimize recovery is that you do the least amount of damage to good cells. So really, in terms of power management, that's really where a lot of the intellectual property that we're generating is being based on now. The actual generation of a high voltage, or let's say DC voltage or something like that, is relatively straightforward. Really, where the intellectual property being developed is in the control of that and the timing of it and the speed at which you can deliver. And that's the same for industrial applications. It's for medical applications. It's for data. It's for data comms. It's right across the board, and that's really where we can separate ourselves from other suppliers.
And you provided a nice segue there, because I wanted to talk a little bit about advanced energy. And you guys are, you're in so many industries, right? You're touching so many industries. What have you seen, in the midst of this transformation and industrial revolution? What's really, and where we are right now, what's really catching your eye as something that's taking off that you're seeing among your customers?
Yeah, I think there's to me there are three key technologies in this as we call the fourth industrial revolution, and they are at different stages. I think everybody is aware of IoT. Everybody is aware of AI. Everybody is aware of IoT. So these are buzzwords that get thrown around a lot. But they to me are the three building blocks in terms of the next generation. And what's coming from that then in terms of artificial intelligence, I mean, we are a pure power play company. That's what advanced energy does. Mm-hmm. We're in a number of market segments. We're in semiconductor equipment. Mm-hmm. We're in industrial and medical. We're in data center computing, and we're also in telecoms and networking. And what's interesting to see is that the AI, artificial intelligence, the Internet of Things, and the 5G are all contributing across those four major industries in many, many different ways. I can talk about the details if you want, maybe just give you some bullet points. Yeah. So in terms of the artificial intelligence, what does that mean for our customers? Well, what it means is that they need more memory. And what that means is new memory architectures. If that means new process and procedures, that means more power, new power requirements. And that's where we are contributing to in terms of artificial intelligence. If I look at the 5G, for example, 5G means higher density memory. So again, that's what we need to do in terms of supplying it. Mobile edge computing as well is very real, and a very real need in terms of 5Gs. So that's generating growth in our industry as well. If you look at the medical sector, 5G by itself now allows you to transmit much more data at a much faster rate, which now means that we can change the whole model in how we receive our treatment. Telemedicine is evolving. Also, on top of that, what you bringing in artificial intelligence, jobs that we would have thought in the past could never be replaced by a computer. Radiographers, for example, you can now have artificial intelligence analyzing data on X-rays, on MRI scans, and also then what you have the ability to share information much quicker. And what's really, what really always grabs my attention when I read about artificial intelligence is that maybe 5 or 6 years ago, what was being done at PhD level is now being done at undergraduate level. And it's not even about the artificial intelligence, it's about the learning mechanisms. The learning mechanisms are all about image recognition, and the image recognition is all about, defining what a cat looks like. If you show a computer every single variation of what a cat looks like, they would get it. That same technology is being applied in, for example, cancer treatment in imaging of moles. So all these things that were very futuristic only 5 or 6 years ago are happening very, very quickly. And each of the segments has a part to play in it, as well as the power industry, because we are the guys supplying the power that enables those technologies to develop. So it's a really fascinating time to be involved in power engineering in particular.
Yeah, I think one of the most interesting things is people don't realize how quickly it is coming about, like how quickly these changes are happening. Now, I have another question, because we talked about some of the things like AI and sort of Internet of Things. What about, and I want to say virtual reality.
Brian's going to come up with something like off the wall. Just be prepared. Robots doing this.
So what about virtual reality? Now, I'm not talking about like I'm putting on my Oculus goggles and looking around. I'm talking about like eventually your whole home, maybe the walls have touch sensors on them, right? Do you know what I mean? And you're able to interact as you're moving through your environment. What type of insane power needs to go on for when we get to that point? Because we will get there. As we talk about all these things being automated, as we talk about the artificial intelligence happening, what happens with the power demand? Like, are we even going to be able to sort of keep up with it, I guess is what I'm asking.
Yeah, I think that's the, again, this is the real critical part. And again, if I take it back to my world where I live in terms of our technology, in terms of what we want to develop, it's no single silver bullet will suddenly fix everything for it. I mean, if we want to build a better power supply, think of what goes into a power supply. You have magnetics, you have capacitors, you have resistors, you have FETs, etc. And what we need is every element of that design to improve in order for us to reach our holy grail of shrinking the size, making it lighter, making it faster. And I think for that type of, if I expand that out to your question then about this, maybe you come in the morning and reprogram your house, whatever crazy stuff is out there in the future. I think every single aspect of the industry has to comply with that. You're talking about sensors, you're talking about visualization, you're talking about power, even just how we transmit power, because the very nature of a wall means that something is wired behind it that you plug into. That's not going to work in a virtual world where you reprogram your house every day. And we're really going far out here now in terms of this conversation. But, I think in terms of breakthrough, it's going to be how we harvest the energy. It's going to be how we transmit that energy. It's going to be how we use that energy. We transmit an alternating current. Our electronics uses a DC current. So we have to make that transformation from AC to DC. Already there are apartments in Taiwan, for example, that only use DC voltage. So the world is continuously changing. And again, like I said, the switch mode power supply didn't change much, from the 50s to the 90s, even the early 2000s. They looked and felt the same. There was incremental improvements. They were a little bit more efficient. They were a little bit smaller. People started to add features. But if I look at what was designed in the early 2000s, and if I look at what's in a power supply right now, and if I extend that thinking out to what it will be over the next 20 years, it is just, operating systems on a power supply. Windows or XP or a Mac operating system on a power supply. Why not? 20 years ago, it would have been unheard of. And that's kind of where I'm saying, in terms of the next generation of engineers, it won't just be analog engineers. In fact, it won't be analog engineers at all. It would be people with just skill sets that we can't even imagine right now. And that's really where the world is going at a very, very fast rate. And, again, I'm an engineer. I like to plot things out. I like to scale it out, and I like to try and project the future based on what I know from the past. And if I do that, the rate at which technology is being integrated into power supplies is incrementally is increasing exponentially year on year. So here's looking to the next 5 years. I'm going to come back and see how much of this is right.
Yeah, we will definitely do that. What about wireless power, right? There's this sort of quest, like no one wants to connect their device. Everything has a power supply, but no one wants to connect it. How is that playing into a lot of designs these days?
I think it's still at its relatively infant stage. There's no doubt about it, in my opinion, that for example, the motor industry is fast tracking that. However, even if I look around my office here, my mobile phone is currently charging on a wireless interface. In fact, if I replace my phone, I don't even use the cable anymore. And actually, what's interesting, and you try to think where that shift in thinking happened. Things like the first iPad, when it came out, it didn't have a USB interface. So straight away that was disruptive thinking, because in the past it was all about storing data locally. That was the first step to getting us away from storing data locally. So if I apply the same thinking to plugging into a device, it started to come into our lives now in terms of not plugging in devices. Christmas time is a good time to take a walk around houses and see so many solar devices, so many solar lights. And in the past, these were very weak lights. They lasted for about 15 minutes and then they died a slow death. Whereas now it's hard to tell the difference between the solar powered lights and the actual plug-in lights. And that is to do with the fact that, the cost is coming down, more technology is being developed. And even in terms of, again, I'm not trying to plug advanced energy too much, but again, that is a big part of our business, is in the manufacture of those solar cells. So that's really where the future is. So in terms of wireless, yeah, I think we're at a very early stage, but there's no doubt about it that my kids are relatively young. I can see a time when they'll be plugging very few things in on a daily basis.
I look forward to that. Enough with these wires.
I think everyone does.
These wires anymore. Just more things for the new puppy to chew on, right? And you mentioned not plugging advanced energy, but to that point, I would like to know, what about what engineers should be thinking about as they're selecting products. So, and I hate to say, what makes advanced energy so great. That's not what I mean, but in a sense, I would like to talk a little bit about, what they should be looking for in a company when they're selecting their products. I know I've seen a lot about repeatability and customer service, even something as simple as that. What are some of those characteristics that you think engineers really, especially now in the climate that we're in, what should they be looking for?
Yeah, I think one of the key words here, one of the key ideas I would have in answering that question is future-proofing your symbiotic relationship with your vendors, not just power, but right across the board. Because again, we've talked about the rate at which things are changing. We've talked about how dynamic things are, and the answer to your question is three very simple words. It's innovation, innovation, innovation. And I am quoting here our CEO from Behind the Bell interview in 2019, and really it is about innovation. And it's not just product innovation. It's not just bringing out a smaller, faster, cheaper design. It's actually making sure that you're engaged with a company who understands you and understands your needs and provides you with high excitation factors. I mean, everybody thinks that, reliability and repeatability and, customer service. However, that is the price of entry level into the market segments that we are going after. So, you know, I never sell to my customer on the fact that we're very reliable. Taken, you know, but what we're doing is that we're working with our customers to uncover their hidden needs, to understand their future needs. Because again, it's not just transactional between us. They want to buy a power supply. We want to sell a power supply. We want to sell solutions. We want to sell solutions that are scalable, you know, modular, scalable. We grow with you. We grow with your needs. Are flexible enough that when you reach your barriers in terms of energy, that we have the power behind us as a company. And that's one of the big things that I've seen since coming from a small to medium enterprise into a much bigger organization. You know, when we were a small to medium enterprise, when I was working for a private company, we focused on one market segment, and that was the AC/DC conversion. Advanced energy has high voltage, has power amplifiers, they've got high voltage AC/DC. You know, the list is endless, but it means all of those under one umbrella really means that we can provide a solution for any customer that we want to support. And that for me would be key. If I was an engineer designing some cutting edge technology, that if and when I run into problems with the power needs, that I have a partner behind me that can provide solutions.
Absolutely. So, you know, a company that has experience in different industries too, is so many of them bleed over each other, like communications and robotics and medical, and, you know, so many industries, you know, span each other these days.
And what's even amazing, Brian, is that you know, it gets power engineers excited. Maybe not the rest of the world, but power engineers get excited. But the stuff that we're developing for the semiconductor business, you know, it's about getting a lot of energy into a small space very quickly in a controlled fashion.
Yeah, we're
exactly the same thinking for curing cancer, or sorry, for fighting cancer, not curing cancer, but for fighting cancer in the medical industry.
Mm-hmm.
It's the very same way in terms of transferring data. So really, you know, it's even though it's 4 different market segments, the core technology is actually applicable right across the board. So that's really very exciting for us in terms of developing innovation.
Yeah, we're over here geeking out with you over the technology.
I'm certainly not an engineer, but Brian can at least hold a conversation, right? Pretty tech savvy, but at least the audience will be excited. That's the most important part.
Yeah.
But you know, Shane, is there anything specifically over at Advanced Energy that you guys are working on that you wanted to talk about? That would be really cool.
Yeah, and I mean, in terms of it, because you know, I did expect this question to come up, and I was kind of doing some research myself, even internally, and some reflection. And honestly, the biggest problem is trying to scale it down into a couple of minutes, because there's so much going on in the company. But what I have done is I have looked at a number of press releases over the last couple of weeks, and we have a really good marketing team that help us promote the company. And you know, if I draw just a couple of examples from the last month or so in terms of releases, the remote plasma source it was recently, the Max Stream was released, and again, you know, it's very reliable and all that good stuff. But really, what gets the customer excited is that we've got industry leading 2% accuracy. Now that might not mean much to the average user, but this is an industry that is striving towards accuracy, striving towards throughput, striving towards increasing the yields, etc., because downtime costs a lot of money, wastage costs a lot of money. So this really is one example of where our technology is helping our customer to grow their business much quicker. So the Max Stream is a good example there of remote plasma sources in the semiconductor business. I also think in terms of the medical sector, you know, what's happening with medical devices. When medical devices are shrinking, you know, they need to be mobile, they need to be portable, they need to be robust. You know, these devices again, you go back maybe 15, 20 years, devices that were the size of a room are now the size of a filing cabinet, and they need to be portable. And the team, you know, one of our teams is working on high power density AC/DC converters. And the CX3000 is a very good example of the technology that's coming out of one of our teams. Up to 24 isolated outputs, again, meaning very little to the end user, but what it means to the actual designer of systems is that one power supply can now power all of their needs. You add in some intelligent communication on that device, and now you've got a way of pulling information from your power supply. You've also got programmable features on the power supply, so you can change the voltage on the fly. So really, you know, cosmetic surgery, laser, driving lasers, all of that stuff, it really makes a huge difference by this technology coming to the market. I'll give you maybe one more example, again, just to show how diverse we are as a company. The Thyristor A+ series is used extensively in controlling energy in large manufacturing facilities such as glass, etc. And really what they're doing is they're striving for accuracy in terms of being able to control the temperatures. So if you can imagine a river of glass, if you can imagine the yield rate on that glass is based on the accuracy of the temperature as the glass goes through that profile, and this is what another one of our teams has been delivering. It's breakthrough in terms of accuracy. It's breakthrough in terms of not so much reliability, because as I said, that is the cost of entry. So that doesn't get my customer excited. What does get my customer excited is that we now have the offer to help them to increase their efficiency, help to increase their improvements, and we can actually quantify that for the user. So if you want to, I could go on and on and on about the stuff that Advanced Energy is bringing up, because it really is. I mean, we've got hundreds and hundreds of engineers working on projects around the globe, everywhere from California to Korea, and everywhere in between. And every day, literally, there's new technology coming out of those engineering groups. So as I said before, for me personally, a really exciting time to be in the power industry, and in particular with Advanced Energy.
That sounds exciting. Is there anything, Shane, that you would like to leave the engineers with today? Anything that they should be excited about looking forward into I know we talked about the next 5 years. Is there anything that you'd like to leave them with today?
Yeah, I think that what was traditionally seen as let's say a not very exciting segment of the electronics industry, and we see it every day. I mean, we have graduates coming out, and we are competing with the likes of the automotive industry. If I come out of university, in my 20s with a master's or PhD, whatever it is, and power engineering is on the right hand side and artificial intelligence is on the left hand side, I know where I'm going. I'm going towards artificial intelligence, because that seems to be a very exciting industry. But what not many people realize is that all of that technology has already morphed its way into our industry, and really we're at the cutting edge of technologies by bringing all those into our designs. And like I said, day one when I graduated in the mid 90s, I purposely picked hardware because my degree was in electronic engineering, and I would have felt an injustice if I didn't at least practice it for a couple of years. But now, as I've progressed beyond the 20 odd year mark, let's say, there is no getting away from software. It's an integral part of our designs. And what it means is that the power industry in particular can offer so much more to our end customers, and customers are starting to embrace that, and they're starting to ask us for more features and demand more features. So again, a really exciting industry to be in, a really exciting company to be a part of, really exciting to be part of the cutting edge in terms of IoT, 5G, artificial intelligence, and we are enablers for those technologies. So, would I encourage my own kids to get involved in it? Absolutely.
That's awesome, Shane. Thank you.
I think to remind everyone, the power is part of the foundation, right? You're touching every aspect of the industry.
Right.
Really
correct, and that's really because even when we think of new technology over the last couple of years, 3D printing is a very good example. Everybody know these. We have these desktop printers, and we're printing in 3D, and it's amazing. But my first engagement was in 2004 with a team in Israel, and it was just mind-blowing stuff. And they had to have a particular profile in terms of energy, which we were able to work with them to supply as a solution back in 2004. Now, it took probably 10, 11 years for it to become mainstream, but the technology was developed 10 years beforehand. And that's what we're doing right now. We're developing right now for what will become mainstream in 10 years' time.
Awesome. Well, Shane, please let everybody know where they can learn more about Advanced Energy and check out what's going on over there.
Yeah, so we have a website. It's advancedenergy.com. We're also on Facebook. We're on LinkedIn. I mean, our headquarters are in Denver, in Colorado, but we have design sites all over the world. I myself am based in Ireland. My own contact details, if anybody's interested, is shane.callanan@aei.com. And if any of your listeners do have any questions or want to bring up any topic of conversation, I'm more than happy to engage with anybody who's willing to talk the geeky stuff, Brian, as you said.
You just got the guy's email address, so go ask.
That's it.
No, please do. I mean, that's why I really enjoy working with this company, because we do really have we have a real culture of sharing. We have a real culture of learning, both from our customers and for ourselves, and teaching our engineering team. And that's the culture that this company, that will drive this company forward, I believe, and why we're getting so many good people coming on board, to help us grow.
That's awesome, Shane. Thank you so much for joining us.
Thank you for your time today. We really appreciate it.
My pleasure, folks.